Hello everyone and welcome to my channel Maths with Lacy Bhai. In this video, we'll be discussing a question of Jee Mains, which is from the topic of limits and derivatives. So this is not a difficult question at all, but you just need to get the trick of this question. You need to understand the logic. So there is a function given, and you can see that on the right hand side there is a heavy expression. So you need to evaluate the derivative of f at the point 0. Now, there are two ways. The first way is finding the derivative of the function using the chain rule, because there are many functions involved in this single function f. Then to calculate the derivative, you need to use the chain rule. But you can see that if you will be using the chain rule, you will have to use the product rule, and that will result in a lengthy and tedious calculation. So whenever you are asked to evaluate the derivative of a function at a point, just try to minimize your effort or minimize your work. So the first thing that you should do when you are given this expression, you should check the value of the function at the given point 0. At the given point, here the point given is 0, whatever it is a in R, so you need to evaluate your function at that point. And if you do this for this f, you will see that since tan 0 is 0 and the denominator is making complete sense, because substituting x equals to 0 gives 1 in the denominator, and in the numerator you have 0, so f0 is 0. So now you can bypass this chain rule by the basic definition of derivatives, which will help you evaluate this derivative using the basic limit calculation. How is it going to happen? See, using the basic definition of derivatives at the point 0 for this function f, the derivative at this point 0 is given by limit 0 plus h minus f0 upon h. Now you know that f0 is 0. So you just need to find out this limit in order to find the derivative of the function f at the point 0. And this is the best part, because if you had done this question using the chain rule, you would have ended up filling your 2 pages of your notebook, at least 2 pages of your register or notebook, and then you would have got your final answer. But using the derivative definition only and taking the advantage of the thing that your function's value at the point at which your derivative needs to be evaluated is also 0. So you can just bypass the chain rule and evaluate this limit and get your final answer. So what will happen if you will try to evaluate this limit? You will be getting fh is 2 raised to power h tan h root tan inverse h square minus h plus 1 upon 7h square plus 3h plus 1 whole cube and upon h. So basically the h goes in the denominator only. Here is h. So you need to evaluate this limit. Okay. Now if I try simplifying the tan, tan h is sin h upon cos h. Now you know that you can, this product of functions, and over this limit is being evaluated, limit is being applied. So you can separate it only if the individual limits exist and are finite. So if you see, then for this function, you can see that you will be getting the limit when h going to 0 is 2. And for this function, you know, it is a very well known result. The sin h upon h is, limit sin h upon h is 1. And you know that limit h tends to 0, 1 upon cos h is 1, because when h is approaching to 0, cos h is approaching to 1. And since there is a denominator, it is just 1. And limit h tending to 0, 1 upon 7h square plus 3h plus 1 whole cube is just 1. And the remaining part you can see that you can take the limit inside, because square root is a continuous function. And if you choose the domain minus pi by 2 to pi by 2, and h is going to 0, so you can choose a very small interval around 0 where tan inverse is continuous. That is the reason you can bring your limit inside your this bracket. So if you calculate, then you'll be seeing that h becomes 0 because h is going to 0. So the limit says that h square minus h also goes to 0, so it becomes 0 for the final answer, and you end up getting tan inverse 1. And tan inverse 1 in this, in this minus pi by 2 to pi by 2, you get on 45-degree angle, or pi by 4. So this is root pi by 2. So you can see that each individual limit exists and is finite. And so you can take the product of the limits to calculate the final limit. So you get 2 into root pi by 2, because the rest values or the rest limits are 1, and this gets cancelled, and the final answer is root pi. So you can see that sometimes questions are asked which are very lengthy when you see them for the first time. But if you know such tricks, then you can make your calculation easy. As you can see that the chain rule, if you had applied the chain rule, it would have just made your calculation lengthy and tedious. But just by observing that the point at which the derivative needs to be evaluated is the value of the function at that point is 0. So your work got reduced a lot to just calculating a basic limit. So thank you so much for watching this video, and see you in the next video. Happy learning!